Hey guys, back again to do more stuff with adding and subtracting vectors. Um, what we're going to look at today is the definition of vector addition. Okay, it's not too long, it's just building off of the stuff we've been doing yesterday, so let's dive into it. Okay, definition of a vector. If U, which is composed of U1 and U2, and V composed of V1 and V2, then the sum of the vectors U and V is U plus V. Okay, and what that looks like is U1 plus V1, U2 plus V2. Okay, we're just adding up the components, our Y components and our X components. Okay, in this application, the sum of vectors is called the resultant vector. Okay, it's the vector we get as the result of adding them together. You can add vectors in component form and arrow form. All right, that means rectangular or like graphically is what they mean by arrow form. So the big thing is you cannot add in polar form. Right here, you cannot add vectors in polar form. So if you ever have it in polar form, you got to convert it to rectangular, add them, convert it back. Okay, that's the biggest thing to take from that. So just adding the vectors right here, let's just add them componently right out here to the side. So we're going to have 2 plus 1, and we're going to have negative 3 plus 4. Okay, that's going to give us 3, 1. Okay, and now when they talk about adding the arrows or adding in arrow form, they're talking about right here how we have these two vectors. Okay, let's just say this vector is U. Say this one's V. Okay. Another thing I want to point out. So first off, what we talk about when we're adding it in arrow form is we want to go nose to tail, and all that means is we want to take our two vectors, and we just want to put them together. Okay, so I'm going to take that V vector and just kind of drag it on over here so it looks like that. Right, that's our V vector. Still there, same thing. I just put it nose to tail. So when we add them, the resultant vector is this vector right here. Okay, you see that? It completes that triangle. Or you can think about it as the two vectors, those two vectors represent one side of the polynomial. Okay, right? So if this is positive U, this is positive V, drawing them backwards is the negative. Okay, so we can draw this line. We could say that's negative U. And then look, if we do that arrow up there, that's negative V. Okay? So when you have two vectors, the resultant vector is the diagonal. Or it's the two vectors are the two sides of the parallelogram, and then their opposites are the other two sides. The sum of those vectors is the diagonal of the parallelogram. Okay, as you can see here with what we drew. All right, but all they asked for was just adding them together. So U plus V, and we get this vector right here in the middle. Okay. Now let's talk about adding forces. Okay. A force is the influence that changes the motions of an object. Okay. If two forces F and G influence the motion of an object at the same time, then H equals F plus G. Okay. And H is called the resultant force. So those are just adding forces. Same thing as vectors. If you got two forces, you add them together. Those which by forces, they're kind of talking about our magnitudes. Okay, our magnitudes combined with our direction. All right, if we got two of them, add them together, you're going to get a result one. So let's dive right into number 3. Okay, good example here. I like this one. Big thing to look at. This image. They don't really give us a whole lot of written written values and stuff like that. They just give us this image we got to work with. So we got to take this image, kind of figure out what these two forces are. So first thing I want to do is where you see these vectors coming out of the lines, I like to draw a crosshair right there. I draw a crosshair right there, okay? Because I want to think about these as almost two separate crosshairs so we can identify what these vectors' values actually are, okay? So when you're looking at this one's pretty easy, okay? We got a vector that is, I'm going to just write it in polar form because it's already kind of there. We got it 60, and it's coming up at 60 or 36 degrees. Okay, that one's pretty easy. But when we look up at the 80 and the 22, you need to notice that when I drew those crosshairs, this vector is going down. This vector is in the fourth quadrant. Okay? If you remember when we have our polar axis, right, that's the x, positive x out here. If we go this way with our theta, that's positive. If we go this way, it's negative. So this is the same thing as 80 negative 22 degrees, right? That becomes a negative because it's going down. It's going the opposite way. And now what they want us to do is give the resultant force in polar form. Okay, so look, we already got it in polar form. We got to convert it to rectangular. Okay, we got to convert it to rectangular, add them up, convert it back to polar. Okay, so let's just dive into this. First, let's start converting these to rectangular. So we should have, and I'm just going to take each of these polars and write it up here in this form. So we got 80 c negative 22 sine negative 22 plus 60 cosine 36 sine 36. Okay, we had those up. We take the next step down. That's going to give us, for our rectangular form, I got 185.4 negative 74.9 plus 242 point, that's a 4, 7, 176.3. Okay, so we got our rectangular values. Now we need to add them up and get our total value, our resultant force in rectangular form. So when you do that, I get a nice 428.1 and 101.4. Okay, so we got it in rectangular form. We got it in rectangular form. We got it in rectangular form, so now we got to convert it back. We got to do our r's and our t's. So if we do the square root of 428.1 squared plus 101.4 squared, okay, we do the our theta, we do our tan inverse of our y over x. I'm just going to write our y over x. You can see what that is. Okay, we're going to get our 13.3 degrees, and we're going to get 439.9. Okay, so look, this is we have our force, we have our direction. Okay, and the key thing is you can notice that's just a little bit up because we got that 60 pounds coming up at a steeper degree. So they say now put it in your own words, or give the resultant force in polar form and interpret your answer. So we can say the car is moving. Okay. So we can say car is moving with 496, or I'm sorry, it's 439.9. 439.9 pounds of force. Okay, at 13.3 degrees. Okay, remember, if it's 13.3 degrees, we know it's coming out of the polar axis, so we're going to say north of east. Okay, not too bad. That's the big thing. We kind of talked about this. I did that again. Kind of talked about this the other day, but a lot of your answers are going to have to be, final response is going to be something like that. Car is moving with 439.9 pounds of force at 13.3 degrees north of east. That is car. Okay. So now, next part of 3. Give the resultant force in polar form in well, wait, we already did that. Sorry. That's that right there. I just wrote it all up there for some reason. Okay. Moving on to 4. Okay, another story problem. Love it. A plane is flying at a speed of 200 miles per hour and heading of 28 degrees east of north. A 50-mile-an-hour wind coming from the east pushes the plane off course. Find the plane's true speed and direction. Okay, so we got our 28 degrees east of north, 20 miles an hour, 50 mile an hour coming from the east. Okay, so let's draw, first let me draw that plane vector, okay? I don't want you guys to be confused about this. So we got a vector, it's coming up this way. They're saying 28 degrees east of north, right? We got our north, we got our east. This is where the 28 is. Okay, it's saying it's coming out east from the north axis. So if that's what that one is, if that's 28, then we know that this is 62. Okay, so for our plane, we have 200 at 62 degrees. Okay, we're going to add that together with our wind. All right, our wind is 50. But what's the angle? Or which way is it headed? It says coming from the east, okay, right? Coming from the east means it's going to the west. So what's that angle? Right? What's that angle if we go all the way around to there? It's 180. Okay, so our wind is going at 180 degrees. Okay, it's coming from the east, headed to the west. So we're going to add these two forces together. Actually, first we got to convert these two forces. We got to add them up, and then we have got to convert them back. So I'm hoping you guys understand the conversion stuff by now. I'm going to just do the conversion in the next line for you. Which I got 93.9 and 176.6. And we're adding that with our negative 50 and 0. Okay. Add them together. You're going to get 43.9 and 176.6. So now we got our resultant vector in rectangular form. We got to take it all the way back. Okay, we're going to do our R. I'm going to go up here. We're going to do our R equals 43.9 squared plus 176.6 squared. We're going to have our theta, which equals tan inverse of I'm just going to write it again, y over x. It's going to give us 76. This is going to give us 181.97. Okay, so you write that in polar form. 181.97, 76 degrees. And that's our final polar point. But wait, there's more. We have to write this in a complete sentence at the end. Okay, so we can say the plane is flying at 181.97 miles per hour at a heading of 76 degrees north of east. Okay. So we could also say that it's going it's going at a heading of 14 degrees east of north, right? That's just the difference. That's just me telling you the degrees coming out of the northern axis. Okay, understand there's different ways of writing all these answers, but they're all still right. Okay, let's go down to 5 now. Relative to water, a boat is moving with the speed of 20 miles an hour in the direction of 15 degrees west of north, due to a current which is moving in the direction 30 degrees south of east. The boat is actually heading due north relative to land. Okay, find the speed of the current. So they're giving us a variable in our addition. Now we gotta find out. Okay, so first things first, we got a speed of 20 with a direction of 15 west and north. Then we got another one that's a direction of 30. We don't know what the speed is, but it's going 30 south of east. Excuse me. They tell us that the boat is actually heading due north in the end. So we have to find out the current speed and the final speed. So first, let's draw our little crosshairs. Drawing our little crosshairs. The first one we know is coming up this way, west of north, right? That's 15 degrees in there. Should zoom in on that. 15 degrees. We know the current is going down here. That's 30 degrees. And we know that the resultant force is actually straight up this axis. Okay, and that's our B force. B force, C force, and then we already know this one is 20. Okay, so that's what all our vectors look like. Now we just got to find all the values that go with them. So first, I'm just going to write those up here. Actually, I'm going to hop to a new page. There's a lot of work on here that I would like to just write out. Okay. So let's write out what let's just write out our equation. Okay, we got, for our boat, we have 20 and 105 degrees, because if we're going 15 past 90, it's 105, right? It's that whole angle. And then for our current, we have C, because we don't know the value. We got negative 30 degrees, right? It went 30 degrees below that positive x-axis. We got the actual at the end, or our final, however you want to write it. And we don't know what our final force is, but we know that it's going straight up at 90 degrees. Okay, so we got a little algebra problem here. So now when we go through, we convert all these to rectangular form. Should get something like this. 19.32 plus c, and we just got to leave this in kind of our conversion form. Cosine negative 30 c sine negative 30. It's going to equal 0 and b. Okay, remember, if we're just multiplying b by the cosine and sine of 90, you're going to get a 0, which b times 0 is 0, and you're going to get a 1. So b times 1 is b. Okay, so that's how I got that actual result. Now from here, we kind of got to do two basic algebraic equations. We're going to do one for our y values, one for our x values. So what I started with was the x values. So what I'm doing is I know that negative 5.18, right? I'm doing these first. Okay, negative 1.58 plus c cosine negative 30 equals 0. Okay, all I'm doing here is solving for c. If you move all that over, you should get c equals 5.18 over cosine of negative 30, right? And that should equal 5.9. That's a 5.98 miles per hour. Okay, and remember that C, that's the current. Okay, so we got our current, we found our C. Now let's go over and do our Y's. So with our Y's, we're doing these now. Okay, I'll just do that right over here. We got our 19.32 plus, we know what C is now. That's the thing. We know what C is. We can plug that in. That's our 5.98 sine of negative 30 equals B. So from here, you can just plug that whole line in your calculator. All right, that's miles per hour. That's our final velocity for the boat. Okay, so you could say at the end you could write, let me go back. Come on. You could write, oh man, I already forgot what it was. The final speed is 16.33 miles per hour. So you could write we're just going to write the boat's final speed is, what do we say, 16.33 0.33 miles per hour due north. Okay, always finish with that nice little sentence. Now we're going to move on to subtracting vectors. Just touch on this a little bit at the end. It's really just the same thing, right? We understand that addition and subtraction are about the same function, okay? The vector negative v, the opposite of v, is the vector with the same magnitude, okay? They have the same magnitude of v and the direction that's opposite to v. Okay, it's opposite. So all that changes with opposite, like we talked about before with the parallelogram, you have the opposite v of the opposite u, okay? Same magnitude, same length, opposite direction. Okay, vector opposites theorem. All that's saying, if v is a vector with polar representation r and theta, then we know that negative v is going to just be our same r, right? The value is always the same, but it's going to be our theta plus 180. Okay? Right? We're just changing the direction. We're flipping it 180 degrees. Okay? So you can always remember the opposite direction of anything is 180, right? We can remember that. Now for B, if V has a component representation, all you're doing is negative V1, negative V2. Just throwing a negative in front of both those components. Okay, easy enough. Now, definition of vector subtraction, the difference, U minus V. That's just the same thing as, hopefully we understand this by now, U plus negative V. Right, we understand that. Now 6, that last thing for today, 6 on here, is pretty much exactly what I did at the very beginning with understanding that, and that's negative U, that's negative V. Okay, so doing these graphically, and that's what they kind of want us to do here. So doing this graphically, it's positive V, which kind of looks like that, minus U. So you could do your, you could do your minus U, which is in this direction, right? I just took that minus U, vector, put it nose to tail, and then this resultant vector is going to be U minus V, right? Okay, for the next part, I'm sorry, that was V minus U. Okay, for this next part, we're doing U minus V, so our U vector goes that way. Our minus V goes down like that. So the resultant vector is going to be our U minus V. Okay, just connect them nose to tail. Remember that when you're doing it in arrow form or graphically, however you want to view it, you're just putting them nose to tail. If you have a U, negative U is the opposite direction, same length. Okay, that's all I got.